Hey everybody, I'm very pleased today to introduce my very first module for Cherry Audio Voltage Modular, Recker, this little guy here. Recker is available for free in the Voltage Modular store. In this video, I'm going to explain the input and output ports and give you a couple of ideas about how you might use this. So here on the side, you can see I've got an LFO, and if we pass that into the oscilloscope, you can see it's a pretty vanilla sine wave, which is what we'd expect. Now I'm going to patch that into this first port here. This port is the input signal for Recker, and once we patch that in, there are 4 different output ports that will modify that. The first one will take whatever we've given it and it will invert it. So any value that was positive will become negative, and any value that was negative will become positive. The second output is half rectification. So this will take any value that was a negative and it will simply cut it off at 0 volts. The third value is full rectification. It will apply inversion only to values that are negative. So in a normal sine wave, you would have a little loop going down here, but instead that negative portion is inverted, so we get an all positive signal. Both half rectification and full rectification can be helpful if you have a bipolar control voltage that you want to use to modulate something and you only want that voltage to add values. This will allow you to basically guarantee that you have a unipolar or only positive signal coming at the other end. Lastly, the fourth output is a combination of the first and third, and this is an inverted full rectification. So you can see we're basically getting that same shape, except it's just inverted. We're now in negative territory. So that might seem simple, but sometimes simple modules can produce interesting results. Let's take a little bit of a listen. So if I just took the output of that LFO, I'm going to modulate the cutoff on this filter. Let's patch in the saw wave here. A fairly straightforward sound. Going through Recker instead, you can tell that's a little bit more subtle. That sounds faster because the negative voltages are becoming positive, and it's causing us to basically sinusoidally go up and down twice as fast. And I've got a much more mellow sound now that we're down in negative territory, as it's dipping the cutoff on down. All right, so that's a simple usage of it. There's a second input port here on Recker, though, that can add quite a lot of fun, and that is a gate input. Now, by default, if nothing is plugged into this port, it will assume that the gate is high. Basically, whenever the gate is high, these outputs will modify the signal, and when the gate is low, they will allow an unmodified signal to be passed on through. So let's take a look at half rectification here. You can see that right now it's basically doing it 100% of the time, but over here I have another oscillator. I'm going to kick this into low mode, and I'm going to patch the square wave into the gate port. Here in blue, you can see when the square wave is happening. And if you look at the green signal, that's what's coming out of Recker, you can see that we only are doing that half rectification when this gate signal is true. Something that is a lot of fun is the gate port here will accept an audio rate signal. So if I bring this oscillator, this is where our square wave is coming from. If I bring this out of low frequencies mode and bring it up to something much quicker, you can see that we're getting a lot more of an interesting jittery thing out the other end. Let's actually have a listen to what this modulating a filter sounds like. So there you can hear that even though we have a very simple module that is performing a very simple operation, we can actually use it to get some pretty interesting results out the other end. And as you go through and play with different ones of these, you'll find that you get really, really interesting results by just combining different kinds of gate signals or different rates of gate signals to the gate input. Let's have a listen to this one. So I think that's pretty cool. You can also, by the way, pass audio as input into Recker. So if I took this third oscillator that I have here, and I'll take the triangle signal out of it. Here's what the triangle sounds like unmodified. So fairly vanilla there. if we take a look at this on the scope, actually I'm going to switch and we'll use that as our main signal. Bring this scale up so we can see. So you can see here that we're very rapidly cutting the bottom off of that. Here's what that sounds like. Let's do the same, but with a saw wave. Now, there's a lot of interesting things that you can do by playing around with the ratio of the speed or the frequency of the gate input and the frequency that your input signal is operating at. So as you can see, by combining just a few simple elements and passing it through what are very simple operations here provided by Recker, you can get some really interesting and complex wave shapes out the other end. Well, that was a couple of ideas about what you might use this for. I imagine that if you play around with this and experiment, you will find a lot of interesting and fun things. Just a reminder, this module is free, so go have a look, download it, and have fun. Thanks, everyone.